Hello everyone, this is Nisita and today I'll be presenting an emerging revolution in cybersecurity, passwordless authentication and cryptographic keys, focusing specially on FIDO2 and web authentication. Passwords have been the cornerstone of digital identity for decades, but as technology evolves, their weaknesses have become impossible to ignore. In this presentation, I'll take you through why passwords are failing us, how passwordless authentication works, the cryptography behind it, and how frameworks like FIDO2 and web authentication are shaping the future of secure login. Let's start with the problem password themselves. Traditional password based security relies on the user's ability to create and remember strong, unique passwords for every service. But in reality, users tend to choose weak passwords like 123456 or their birthday. Even worse, the same password is often used across multiple platforms. So if one site is hacked, attackers can easily access multiple accounts. Another major issue is phishing. Users are tricked into entering their credentials on fake websites that look identical to real ones. Once credentials are stolen, they can be used instantly. In short, the password problem isn't just technical, it's psychological. Human behavior makes traditional authentication unreliable. So, why do we need to move beyond passwords? Because they depend on humans and humans are family. We forget passwords, write them down, or choose weak ones. Even the best password policies like forcing uppercase, symbols, and resets every 90 days only frustrate users without eliminating the risk. Most cybersecurity breaches trace back to stolen, weak, or reused passwords. According to studies by Verizon, over 80% of data breaches are due to compromised credentials. So, the real solution is not to make passwords more complex, it is to remove them entirely from the login process. Passwordless authentication is a modern approach that removes the need to remember or enter passwords altogether. Instead, it uses cryptographic credentials stored securely on your device. It combines two factors something the user has, like a smartphone or security key, and something the user is, such as fingerprints, facial recognition, or voice. When you log in, your identity is verified locally using biometrics or a secure key and then confirmed cryptographically to the server. For example, when you unlock your phone with a fingerprint and log in into your Google account without typing a password, that's passwordless authentication in action. Now let's understand the cryptography that powers this system. Passwordless authentication relies on asymmetric cryptography, also known as public key cryptography. Here's how it works a private key and a public key. A private key is generated and stored securely on your local device. This key never leaves the device. A public key is shared with the server during registration. When you try to log in, the server sends a challenge, a random one time value. Your device signs this challenge using its private key, and the server verifies it using the stored public key. If the signature is valid, access is granted. No passwords, no secret exchange, no vulnerability. Even if hackers breach the server, they only get public keys which are useless without the corresponding private ones. To make passwordless authentication universal, we needed global standards, and that's where the FIDO Alliance comes in. FIDO stands for Fast Identity Online. It was established in 2013 by major tech leaders including Google, Microsoft, PayPal, and Lenovo, among others. The mission was to develop open, interoperable standards that could replace passwords across platforms. Over time, FIDO developed a series of specifications starting from U2F, Universal Second Factor, to FIDO 2, the modern complete framework for passwordless authentication. FIDO 2 is the heart of passwordless revolution. It combines two main standards, web authentication and CTAP. Web Authentication API developed by the World Wide Web Consortium W3C. This allows browsers and web apps to communicate with authenticators. CTAP, the Client to Authenticator Protocol developed by FIDO Alliance, which defines how a device, like a laptop, talks to an authenticator like a phone or hardware key. Together, they enable a seamless login process across websites, apps, and devices using cryptographic authentication instead of passwords. This makes FIDO 2 not only phishing resistant but also cross platform compatible. Web authentication is how is this technology integrates directly into your browser. Instead of showing a password field, a website using web authentication can prompt you to authenticate with your fingerprint, face, or a security key. It defines three core functions: register, verify, authenticate. So, register when a new key pair is created, the first step. The second step is verify when the public key is stored on the server. The last step, authenticate when the user signs in using the private key. Modern browsers like Chrome, Safari, Edge, and Firefox fully support web authentication, making adoption frictionless for both users and developers. CTAP, or Client to Authenticator Protocol, acts as the bridge between devices. There are two main types of authenticators: external authenticators and platform authenticators. So, the first one, external authenticators like UV key or Titan key connected via USB, NFC, or Bluetooth. Platform authenticators built directly into your device like Windows Hello or Apple Face ID. CTAP ensures that communication between your browser and these authenticators happens securely, facilitating key generation and challenge signing without ever exposing private keys. Let's now walk through the entire FIDO 2 authentication flow step by step. Registration phase. When a user registers, the device generates a public private key pair. The second one is the key transmission. The device sends only the public key to the server. The third one is the server storage. The server saves the public key associated with your account. The fourth one is the login phase. When you attempt to log in, the server sends a random challenge. Fifth one is the signing process. Your device signs this challenge using your private key after verifying your identity biometric. The last step is the verification. The server checks the signature using your stored public key and access is granted. This process ensures that no secret is ever transmitted and every login is cryptographically unique. This approach revolutionized both usability and security. From a security standpoint, it eliminates centralized password databases, meaning there's nothing to steal, nothing to guess, and nothing to phish. From a usability standpoint, users don't need to remember or reset complex passwords anymore. Additionally, all biometric data stays local. When you use your fingerprint to log in, that information never leaves your device. It's simply used to unlock your private key. Overall, passwordless authentication solves the biggest cybersecurity problem of the internet era. The technology isn't just theoretical, it's already being adopted by major companies. Microsoft uses FIDO 2 in Windows, Hello, and Azure Active Directory, allowing employees to log in without passwords. Google uses passkeys that link to your device, syncing securely across Android and Chrome. Apple has integrated passkeys into iCloud Keychain, leveraging Face ID and Touch ID for seamless authentication. And platforms like GitHub and Dropbox now support FIDO2 hardware key logins for developers handling sensitive repositories. These adoptions prove that passwordless authentication is mature and enterprise ready. While the benefits are clear, the transition does come with challenges. Organizations need to ensure smooth device enrollment, meaning every user must register the primary authenticator securely. Next is device loss and recovery. What happens if someone loses their phone or key? Secure fallback options like backup keys or re enrollment must be built in. There's also cost and complexity when deploying physical hardware tokens in large enterprises. And finally, ensuring browser and OS compatibility across devices. The direction of authentication is crystal clear and phishing resistant, passwordless, and cryptographic. In the coming years, enterprises and individuals alike will move toward systems that rely on what you have and what you are instead of what you know. Imagine a world where your identity follows you seamlessly from phone to laptop to car, all verified through secure digital credentials, not passwords. That's the vision FIDO2 and web authentication are bringing to life. To conclude, passwords have served their time, but they no longer serve our security needs. Passwordless authentication represents the next major step in cybersecurity evolution, offering simplicity for users and robust cryptographic protection for systems. FIDO2 and web authentication combine the power of asymmetric cryptography, biometric verification, and cross platform compatibility, creating a login process that's both frictionless and highly secure. As adoption grows across industries, the future truly is passwordless. It's time we move away from outdated password system and embrace a safer, smarter, and simpler authentication experience. Thank you for listening. I hope this presentation gave you a clear understanding of how FIDO2 and web authentication are not just changing the way we log in, but redefining digital trust itself.